Good morning, everybody. My name's Stan, and welcome to Bar Z. And in our last episode, we were cutting a V-notch in a tool block. And this thing must have been invented on ancient Indian burial grounds. It's given me nothing but problems. We didn't make one. We didn't make two. We made three. The very first one we built, we put the wrong relief in it. We were measuring from an old unit, and I guess they changed their design from the older ones to the newer ones. That's a 1/2 by 1/2 relief down the center of the V-groove. You see the new one's got a 3/8. So this didn't sit on the bar right. This is supposed to go down onto a bar. It's two V-notches that work against each other. You got the little one that I demonstrated in my last video, and a larger one that sits on a large round bar. So this one was a fail, and we didn't catch that until it already went to heat treat. So that one's junk. The next one, took it over to heat treat, and they thermal shocked it. Take a good look at that. Take a good look at that crack down the side. This one's impressive. Look at that one. And it started from a radius. Look at that radius in there. Look at that crack going all the way across it. And all the way down the other side. Almost all the way through. And then there's another one coming off of that V-groove that runs down. So this thing's junk. There's two more on that, from that sharp inside corner. Now, from what I understand, they had one of the new guys over. This actually went to a heat treating company, and they had one of the new guys doing it. And he pulled it out of the autoclave and dropped it in a pot of room temperature, not even preheated, salt water. It was supposed to go into preheated oil. So if you want to know what thermal shock looks like, that's what it looks like. Maybe in a later video we'll split this thing up, and it looks like I could smack it with a hammer and open it up. It might be fun to look at the grain structure. But anyways, that's take two. This is the one that was actually in the video. I was cutting that little V-groove right there. And it was a real sharp V-groove, you see, where the crack started. And then down the bottom of the 3/8 relief, you can see it's a pretty sharp inside corner. So, the guy at the heat treating company, he was first to jump on it and go, oh, well, you should put radiuses in there so it wouldn't crack. And I said, dude, there was a radius right there, and it still cracked. And look at that. That crack's running right down that radius. I go, it doesn't matter whether that had a sharp inside corner or a radius. But you know what? Let's give them what they want. Anyways, second fail. Here's the third one. And again, with the radius. And I did the V-groove with a radius, which is going to make for a lot of grinding. This thing's through hard. I don't have to worry about it. I can grind as deep as I want. And then I put a radius at the bottom of that too. So there's our third tool block. And Brian Block had actually made a comment in my last video, why don't you just grind the bottom flat until the V-groove lines up? Well, the trouble is we're working one V-groove against another V-groove, and that V-groove height is critical against itself. So the name of this video is Where Do You Start? We've got a tool block, and it just came back from heat treat, so we have no trustworthy surfaces. And we're going to start with all the non-criticals first, which is non-critical dimensions are bottom and top. All they have to be is parallel. There is no dimension. There is no dimension there. So we're going to start with those and get two clean parallel surfaces. We're going to take it over to the surface plate, set it down, make sure it has no rock, and make sure it sits flat. So so we've got a nice stable starting surface to maybe make our first grind. If we have to pack it, we will. If we have to stone it to knock a high spot off or something, we will. Whatever it takes to get it to lay flat on the surface grinder to get our first grind. And then we can flip, get our second grind, and that's just flat work. And all we're shooting for is parallel at this point. So we get these two parallel, and then we're going to take it from there. And this video is all about the step of operations and where do I start. It's kind of like machining a piece of cast iron, it's all rough everywhere, and you look at the thing and you go, damn, where do I start? So, and we've got a new tripod set up today. My last video, when I went to edit it, it looked horrible. Every time that milling cutter came in contact with the work, it would start shaking my tripod around. Now I've got a pretty heavy camera, and you know, this is what I was using. I thought this was going to be awesome. This is a Noga double mag base with a rod and an arm coming off of it, and then I just plopped it right down on the milling machine table and did my work. But I got to apologize. That video was horrible. Every time that cutter came in contact with that, this thing would shake, rattle, and roll that poor camera around, and camera trying to focus, autofocus, and it was distorted and everything else. So getting rid of that. I thought that was going to be awesome, but not so awesome. All right. Anyways, let's go. I'm going to get over to Surface Grinder and go ahead and parallel this up. You guys know what that looks like. I'm not going to show it on camera, but I do want to warn you that you need to get one surface flat first, and then we're going to go from there. I'm going to show you how to, after you get two parallel surfaces, then we're going to start squaring and square the outer dimensions. And keep in mind, we're trying to keep those V-grooves centered to this. So even what if we took 5 thousandths off of this side and 6 thousandths off of this side? We're off center here, but that's why we left a grinding allowance. You know, we may have to pull more off of one side than the other to get it cleaned up and to get it straight and all that. But you know, the V-groove is pretty important to stay centered. So we're going to be checking that as we go to make the determination. Do I take the material off of this side, or do I take the material off of this side to bring it to size? It's a very specific size I need to bring it to. All right, and we'll show that, but let's get this flat work done. Okay, well, I already had to switch up my game plan. This piece around this bolt hole that goes all the way through, if you remember on the bottom side, it's got a large counterbore on it, and during heat treatment it had crowned. So I had a high spot running around right there in the center. I polished a little bit of it away on the surface plate with some lapping film and tried to get it down. I tried to knock it down with a stone. When I set it on the surface plate, I was getting about a 3/1000 rock. It would sit there in a high center. So we're going to get rid of that. Got it clamped in a vise, and we're changing our game plan a little bit. I've got 2 gauge pins underneath it right there. I don't know if you can see those or not. Those are 125 thousandths gauge pins, and they're splayed out to miss that high spot in the middle. So they're actually running out like that. And so we've got it in there squarely. This surface is proud, plenty of room to grind. There's probably, you know, 150 thousandths or so there. We're subsurface here, and we're sitting proud over here. So you clamp it in a vise that you know and trust, and that you know is square. So we're going to come in here, we're going to grind the base. This is the bottom, and then we're going to flip, and we're going to grind this backside of these 2 lands right here, and that'll get us 90 degrees. And we'll use this as a point of reference to grind, you know, all our grooves and everything. So we know our grooves are 90 degrees from the base. And after we've got a base grind here, we can do a parallel on this backside. And from these 2 lands right here, we can use this as a reference when we pull the block out to grind here. So we'll be square, parallel, okay? And then when we go to do the sides, all we have to do is flip this block in the vise and repeat the process. We'll get a nice square grind. So we changed our game plan already, so we're going to go over to the grinder and grind here, and go from there, you know. Okay, well that was the bottom grind. I fast forwarded through all that. You saw me go across with a pretty heavy cut. That was about after I touched one corner. I knew I was a little bit, there was some distortion there. So it was about 2 thousandths distortion. So I did a 2.5 thou down feed, and then some pretty heavy step overs, half a turn, which is 50 thousandths step overs, and just plowed the material off. Then I went back, did a 3/10 down feed, and did 20,000 step overs for a final, just to make sure I didn't burn it or put any grooves or anything in it. But now we know we've got a nice flat surface here. We got to get the vise cleaned up, we got to get the mag plate cleaned up, and flip, and we got to grind this side over here. So I'll bring you back for that after we wash all this schmutz off of there. All right. Okay, we changed the camera angle a little bit for you, raised you up. I got the vise cleaned, the plate cleaned. These plates are so soft that every time in between, take yourself a precision stone, run over it, make sure there's no pimples or anything on it. No up stickers, as Renzetti likes to call them, and Lipton. Anyways, we flipped the vise, sitting down tight on the plate, clean the vise, clean the plate, and we haven't taken anything out of the jaws. Everything remains where it is. You have to have a trustworthy vise. I trust this one. And we're going to make the grind on these two little lands right here. And then at that point, the only thing we know is we're 90. And off of this surface, we can get parallel on the underside. But this is killing two birds with one stone. We're getting a surface to start with, which is our base, where the actual thing sits. And we get a 90-degree reference, because this is where our bar goes in. There's a bar that goes in here to this machine. And after we're all done, we'll assemble it, and I'll show you what it is. But all you got to do is get this grind done, and then it's ready to come out of the vise. So let's get that over with. Okay, well there we got it. We can take it out of the vise now, clean it. We stone the edges. You're always going to roll a little wire edge. Anywhere you take a ground surface to a ground surface, you make a sharp 90-degree corner, you can have a wire edge right there. So we're going to stone the corners to make sure it lays down on the surface plate flat and everything. And so we're ready with this surface and this surface. I guess we can do a squareness check, and then we'll come back and use this large surface to get the top side parallel. That's up next. Okay, I hope you guys appreciate this, because it took a while to set this camera up so you're looking at it just right. What we're doing is I got a cylinder square in my right hand, I've got the part in my left hand, boom, and there's a flashlight behind there. You're welcome for that. Okay, so we're going to tip around. Everything's made it up. I cleaned everything pretty good. We're just going to roll that cylinder square down the full length, applying a little bit of pressure into the part and pressure down against the plate. And you see when I separate, you can see the separation there. And even a tenth of variation will give you a small amount of blue light. There's a little bit right there. Oh, I'm going over that bolt hole. That's where you're getting that little wink of light there, where I'm going over that. I'm going over that bolt hole there in the middle. Okay, interesting. All right, well, boom, there you go. We're square, and now we're ready to, we've got a bottom surface that we trust. We can drop it down on the plate, get that top parallel. That's next. Okay, we're back from the surface grinder where we paralleled up the third side. We've got the bottom and this back side that we already established was 90. We checked that with the cylinder square, so that was good. And we plop it back down on the plate, do this, do a quick check here, run a diagonal, make sure we're all paralleled up, good, happy. All right, so now we're ready to start working on the sides. Now everything we've worked on so far is just geometry, no dimensions. But we're coming up on our first critical dimension, which is the width. And we want the width, and we want to try to keep this V-groove in the center. So we basically want to take off equal amounts from the sides. But I'm telling you, I checked it earlier. There it is. I don't think you can hear that. Hopefully you can hear that. it doesn't sit flat. And over here, which way was it? There it is. Doesn't sit flat. So out here in this corner, it's sitting kind of proud, probably swelled up a little bit during heat treat. And that's why I'm saying that you can't trust a heat treated part, and you got to have somewhere to start. So we can't rely on these surfaces to do any grinding. It won't sit flat on the mag, and the part will actually move during the grinding operation. And we'll end up with a bow or a saddle or something funny with the grind. So we're going to put it back in the vise, use our two parallel surfaces, and get one side here squared up, and at least get one side flat that's measurable. That way we can flip it, have something flat to set on, and grind the other side. And then we need to start working on taking off equal amounts off of the width. So that is next, but we have to do it in the vise. Okay, well, we're back at it, and we already know that our corner over on the right back is our high side, and we know we got about 5 thousandths to plow off of there. So it's going to be the same drill as before. You know, touch off, back out, drop down 5 thou, do a bunch of small steps to remove the material. Then we're going to go back and maybe take 3/10 off of it. So we just need to remember how much we're pulling out of it. That's all. All right, but it's like I said, it's more of the same. Anytime we do an unfinished surface, you know, we need to do basically, it's like milling. You know, you do a rough, do a rough grind, and then you come back and do your final cut. The only cut that matters is the last one. All right, so let's get to it. I'm still seeing sparks, even though you might not be. There's just a tiny little bit there, just as that wheel comes trailing off. Every bit of your wheel has a job. The leading edge does the heavy lifting, and the trailing edge just takes off little bits as it passes by, and we get good averaging on the way by. All right? Alrighty, well, we're off of the vise now. We can work right down on the plate. What's sitting down on the plate is the side I just ground in the vise. So this is actually the last side. Now I did record, I don't know whether I mentioned it or not, but I recorded how much I plowed out of the bottom side when it was in the vise. I did a 1,000th touch off, and then I did another 5 thousandths down feed for a total of 6 thousandths. So I'm going to get the geometry right first, but while I'm doing it, I'm going to go ahead and do the same thing on this side, pull out another 6 thousandths. That's going to keep our V-grooves centered within reason. All right, and then we'll take it over to the plate after the geometry's right. Then we'll work on the dimension. Okay, so we haven't touched yet. We're ready to touch off and get going here. All right, that's the end of the big ugly grind. Not much heat detected there. A little bit, not a lot. We're going to go ahead and do our little 3/10 down feed and just kind of spark out across there, and just do a light dusting and get a nice finish on there. That's exactly what we did on the other side. So we're trying to match that as much as we can. So let's do it. And there it is. Remember what I told you, the only cut that matters is the last one. Ugh. All right, let's get it cleaned up, and we're gonna go, I've got a sample that fits in the groove of the machine that this has to fit into. So we can do a comparative measurement between the sample and this and see how much more we have to take off. But now we know whatever measurement we get, we need to cut it in half and take that amount off of each side equally. All right, but we've got the geometry correct, got rid of all the hoops, and makes, you know, it's not going to sit cockeyed anymore. It's ground both sides now. All right, so let's go get this cleaned up and back over to the surface plate. Okay, well, we got our sample here. This fits in the machine perfectly. This is an auxiliary base plate when they don't want to use a tailstock. So this is basically what I'm building, but it's just to hold the bar, not to hold the bar and a dead center. So that's the piece that fits in there. So this is the width I'm shooting for. So I've already zeroed up on this piece here. And here's our sample of what we've been working on. And it's ground both sides. We just took it off the surface grinder. I took it over there and cleaned it all up and knocked the corners off with a little real fine stone. So we're going to slowly compare these. Oh, it's a good sound. Kind of squeaky. So we're just going to let that gauge climb. I know we're bigger. I can feel that we're bigger, but I don't know by how much. 5, 10. Well, that's easy. So it looks like we're about 10 thousandths big. I'll check that again, but I think we're just a shade under 10 thousandths. So that's an easy, that's easy to do. We just split that number in half and take that much off of each side, you know. So geometry right, we can see there we're parallel, looking good. And now all we have to do is, geometry's right, now all we gotta do is get it to size. And that'll be another hurdle out of our way. And then and only then can we start working on those V-grooves. We gotta get the geometry of the block right, because the V-grooves index onto the sign plate and everything else on the sides. So the geometry has to be right for the V-grooves to come into place. All right, so let's get to that. I'm not going to show all the grinding. You know, it's real repetitive doing this flat work, so I'm just going to go get this thing to size and then maybe bring you back for the last little bit. Remember, we've got this side ground. Those two lands there for that V-groove are ground. And we're square. I checked it north, south, east, and west on all four corners, so we're sitting square there. I still have to do this top here. This length is not critical. The only thing that's critical are those V-grooves. We don't care how long this is. All we care about is where that center hits. All right? So let me go get that flat work done. We'll come back and do another measurement, and then we can move on. Okay, so we're back from grinding. And if you remember, I said I needed to take 5 thousandths off per side. Erring over the cautious side, I took 4.5 thousandths off per side. So I've been very successful at removing material, but I've been unsuccessful at putting it back. So let's just, by all rights and reasons, total, we should be a thou high. Let's see what we get. Oh, look at that. Bing. That's a thou right on the nut. So still need a half thou out per side. And you know what, just for the hell of it, we'll check it in the machine to see if it fits. It's a pretty tolerance fit. It's like, well, let me go show you. I'll break the camera down and take you over to this little metrology machine and show you what it's all about. Okay, there it is in the back. Let me move some of this stuff off the plate that I've been working with here. This guy here, that block goes in on this end of this little way, and then you've got adjustment in and out here. That bolt goes through the big center hole in that block, and then there's a column that stands up there that holds the center, and it holds a gear. And that gear meshes up with a precision ground gear here, and then they just spin the gear by hand, and that'll give them an indication on the gauge of the pitch angle run out. You know, that's where gear actually matters, where it makes contact. So it's made by the Aircraft Products Company, and it's called a Vera-Roll. Pretty cool little machine. It's got ounces of preload into the gear here. Over here there's a spring tension. It's just a really cool machine. And it's a one-trick pony. It's just made for measuring gears. Anyways, this is their existing base plate I was measuring off of. And that is oh yeah, it's a really nice fit in there. I'd be surprised if mine fits. I'm thinking I'm going to be too tight. So it does need to slide back and forth in there. Let's see what I get here. Well, it fits. Oh yeah, but it's a little snug. Yeah, let's not do that. I don't want to get that thing stuck. All right, I'm going to go ahead and plow a thou out of that. But I thought you guys might be interested in seeing that that contraption right there. It's pretty neat. After it's all done, we'll maybe assemble it and see what's going on with it, but pretty cool. Okay, well, we're back at the business end of this gear measuring device, and there's our test block, the one that fits, but man, it's even tight. And I got these now. I plowed another thou off of that block, and she's pretty snug. And let's drop ours back in now that we pulled a thou out of it. Same. It feels about the same to me. So it's pretty snug. I have sharp corners on mine, and if you look closely, I don't know whether you can, I can even get it close enough to see those chamfers. There's one. There, you can see the chamfer on it. So before I take off any more width on this, because right now on the comparator stand, they're within this is within 1/10. This is 1/10 big, but it's within 1/10. I want to chamfer the corners and see if that's an inside corner doing me dirty there, or what it's doing. So I think these sharp corners might be causing me some problems. Let's go talk about how we can put chamfers on the surface grinder and the different ways to do it. So let's talk about different ways to chamfer stuff. Here's our block, and there's about 2 or 3 ways to do chamfers on a part to grind them. If we pretend that wire brush is the fence of my mag plate, we'd use the back fence. Your fence needs to be trammed in and ground in and parallel to the axis of the machine. But you would dress a wheel at a 45 and just use the back fence, bump into it, make a grind, flip, make a grind, flip, make a grind, flip, make a grind. And anywhere, as long as you're at this elevation, it's going to be the same settings on the machine. So you could bump it in here, grind, flip, grind, you know, so you could get quite a bit done off the fence. But you're going to sacrifice a wheel, and you're going to, you know, you're going to, if you had a wheel that was dedicated for flat work and you lob it off at a 45, you just ruin that wheel for your flat work. So it turns that wheel kind of into a one-trick pony. So if you don't want to do that, the other way to do it, this is a magnetic transfer block. It's a nice little brown and sharp, very accurate. And you could just plop your part in like that and run over the top with a regular flat wheel. Just come across just like your surface grinding every other thing. Just grind there, flip, grind there, flip, grind there, flip, grind there. Then that's done. And then let's see how sketchy this looks. Well, that would probably hold. This is super low pressure operation. I don't think that would give you any trouble. So you could grind there, and you could grind there, and you can grind here, all at the same elevation setting. The only tricky one would be that little recessed one right there. That might give you some worries, but this is probably what I'm going to do. I've already got a flat wheel on there. I don't feel like changing out the wheel. Mainly I'm lazy. The other way to do it would be with an actual magnetic V-block. This is a Starrett number 566, and this is an interesting little monkey. It's got 2 V notches. It's got a little one on the bottom, big one on the top, and it's got a squaring block in the back, which is also magnetic. You can actually stick something on here. Oh, it's got some residual in there. But you turn that dude on, and those 2 things are as one there. But you'd use that as a squaring block. If it's, let's say this top was out a square, but I've got a good surface here on the back, what you would do, is that even in frame? Let's get it in frame. There. There, you can see that. So you would take this, put put either a gauge pin or a gauge block underneath it so that the lower magnet has no influence on the part, and let the magnet suck it over to the squaring block, and now you can grind this top. So that's handy, but also, turn this guy off. You can also do parts very similar to the Brown and Sharp that way. Okay, so that's how you would do that. So it's either the fence with a 45-degree dressed wheel, a magnetic transfer block, or an actual magnetic block. Those are the only three ways I know how to make chamfers. But I'm gonna go get some chamfers on this. I think I'm just gonna use my good old Brown and Sharp and be off to the races. Alrighty, well, we're back at it. I'm hoping that the autofocus doesn't go bananas every time I move that table in and out, because there's going to be a lot of that going on. Okay, I think it'll be okay. Let's try it. And we're just going to get a down feed set here to where we like the looks of the chamfer. And I'm going to set a 0 on my wheel up here so I do them all equally. It'll look super cool that way. And we're going to set a 0 for right there. And come down to there. All right, I'm on my 0. Let's do it. Let's see how that one looks. Well, it's certainly getting there. For those of you that watch Rat Rod Bob, he's a pretty cool YouTube channel. I watch him. As he would say, we're getting it, we just ain't got it yet. He's from Mississippi. Good old boy. I think I'm gonna go with another 5,000ths. We're getting close. And you know, like I said, after I get this dialed in, I just got to hit that 0. I'm re-zeroing the wheel again. After I get this dialed in, I just plug in. We know we've done a total of 15,000ths now from a touch off, and I got the wheel zeroed for this corner, this corner, this corner, and this corner. So I can do all those without having to switch up the machine. Oh yeah, we happy. I bet you that's right where I want to be. Yep, she's looking pretty good. Let me see if I can get you a better shot. I don't think you can see what I'm doing very well. I'm gonna try to get you overhead. Oh damn, I just stuck that on the plate. Oh, what a knucklehead. Okay, well there's my chamfer right there. And here's my sample. And they're pretty darn close. I'm pretty happy with that. So I'm gonna try to make it match the manufacturer as close as I can. So that's a touch off plus a 15,000ths down feed for when I go to set my other sides. But I'm good and set now to do these four sides and just work my way around the block. Okay, well the magnet's on and that's a little sketchy for me, so I'm not going to attempt that. I can pull it off by myself, so that's a little too much stunt machining for me. Let's see how this one feels. That one too. Let's switch to the Starrett and do the other long ends. But there is, try to let it focus on the chamfer. There it is in the light. Looks pretty good, matches the other one just fine. But I'm going to switch over to the Starrett block and
Try that. Okay, well, I switched over to the Starrett block. It's got better holding power for stunt grinding like this. You know, that's a lot of stick out there. But super low pressure operation, touch off, plus 15 thousandths. And the thing about this is you don't have to release the mag plate, you just release the Starrett, and you can get your part out. But that's oh, let's see if I can get you on it. That's a good looking corner there. Focus. There it is. See? That's how that's going to look after we get all the way around it, you know. So we're going to do, let's see if we can do this side. And we're going to go back to our 0. And there you have it. Let's try to focus on that corner. Those chamfers all converge together. They're all the same depth. They're nice and parallel. And the block just feels nice in the hand now. It makes a difference, but I took the time to go around and chamfer all the major surfaces just like the other one. Hopefully it'll fit better in that gear machine now, but I'm going to give it another cleanup. And our video's running long, you know, and it's going to take us a while to do these V-grooves. We're working one V-groove against another V-groove, and we've got a very specific distance we got to do. I think we make a standalone video for that, but this block geometry-wise is good to go. All we got left is 2 V-grooves, and this block will be finished. All right, I appreciate you guys watching, and we'll see you on the next one.